Okay, number 8 now. We're given the base and the area of a rectangle. We got to find the height. So here, I just used the formula. Base times height equals the area. So to solve for h, I divided by 12, and I got the height was 7 centimeters. That's because the area was centimeters squared, and the base was given in centimeters, so you can assume that the height is also in centimeters. Okay, if a square has a perimeter 80, then that means that each side has to be 20, alright, 80 divided by 4. And then since a square has equal sides, you just square the side length to find the area. That's why it's called squaring something. When you square a number, you're finding the area of a square with that side length. So the area of a square with side length 20 would be 400, and we're just going to write it in square units because 80 wasn't given in any particular unit. Okay, number 10, we're given that the area of a rectangle is 300 square centimeters. We need to find the length and the width, and the ratio is 4 to 3. So what we could do is express the width as 4x and the length as 3x, because no matter what, if you divide 4x by 3x's, the x's will cancel out and you get 4 over 3, which is a 4 to 3 ratio. So we do length times width, and we get 12x squared is equal to 300. Divide both sides by 12, we get x squared is 25. Take the square root, and you get x is 5. Now negative 5 also works, but that can't be a side length, because if we plug in negative 5, we get that this side is negative 15, so we're going to just use positive 5. So the length could be 15 and the width could be 20 if we just plug 5 into 3x and 4x. Okay, in 11, they give you all the information you need. It says find the area of a rhombus with diagonals 12 and 16. So the formula for the area of a rhombus is diagonal 1 times diagonal 2, and then divide by 2. So that's what I did here, and then divided by 2. And you get, well, I didn't divide by 2. Wait, oh, I did. So you get 96 square units. Okay, in 12, we have to find the area of a rhombus with a 45-degree angle and a perimeter of 40. So that tells us that each side is 10, and one pair of opposite angles is 45, and another pair of opposite angles would be 135, because this is a parallelogram. So, you know, consecutive angles are supplementary. Alright, so we need to find the diagonals. So what I'm going to do is draw the diagonals, and since it's a parallelogram, it's going to bisect these angles. So this angle would be 22.5. So now we can use that and 10 to find half the diagonal by doing the cosine of 22.5 is equal to the adjacent leg, because the diagonals of a rhombus are perpendicular. So x is the adjacent leg and 10 is the hypotenuse. And when we solve by cross multiplying and doing 10 times the cosine of 22.5, we get that that comes out to be 9.23. So that tells us that half the diagonal is about 9.23. Then you could do the same thing with sine to figure out this part of the diagonal. So you could do the sine of 22.5 equals x over 10, and when you cross multiply and do 10 times the sine of 22.5, you get that that comes out to 3.82. So now we could just take those diagonals and double them. So 9.2 doubled would be 18.4. 3.82, we'll just round it to 3.8. 3.8 doubled would be 7.6. Alright, so that would be diagonal 1 times diagonal 2. Multiply that by 2, and you get that the area comes out to be 69.9. And we would do that in square units for number 12. Okay, in 13, we got to find the area of a square whose diagonal is 10. So a square you could think of as two 45, 45, 90 triangles, because a square is also a rhombus. So if you draw that diagonal, it's also a parallelogram. It's going to bisect those angles. So if the legs we call, or the sides we call x, then this hypotenuse would be x root 2. So when you divide by root 2, you get that x comes out to be 5 root 2. So if you simplify 10 over root 2, you get 5 root 2. So then we could just take that side length and square it, and we get 25 times 2, because 5 squared is 25, root 2 squared is 2. So we get 50 square meters for the area of that square.